Lesson 12.3, 12.4, Sector Area, Arc Length, and Inscribed Angles. Your objectives are to find the area of sectors, find arc lengths, find the measure of an inscribed angle, and to use the properties of inscribed angles to solve problems. The vocabulary is sector of a circle, segment of a circle, arc length, inscribed angle, intercepted arc, and subtend. The sector of a circle is a region that is bounded by two radii of the circle and their intercepted arc. We name this with three letters, sector ACB, and the area is pi r squared times the measure in angles over 360. So the measure of the arc. The area of a sector is a fraction of the circle containing the sector. To find the area of a sector whose central angle measures m degrees, multiply the area of the circle by m degrees over 360. Write the degree symbol after m in the formula to help you remember to use degree measure, not arc length. Find the area of each sector. Give answers in terms of pi and rounded to the nearest hundredth. So, we want to use the formula for area of sector, which is A equals pi r squared, m degrees over 360 degrees. Substitute 12 for r and 131 for m. So pi times 12 squared and 131 degrees over 360. We simplify and we get approximately 164.62 meters squared. A segment of a circle is a region bounded by an arc and its chord. And the area of a segment equals the area of a sector minus the area of a triangle. So this is a segment. We've taken the chord and then the boundary or the arc of the circle, and the area of this little piece equals the area of the whole sector minus this triangle that we have here. Let's find the area of ALNM. So ALNM, this part here, to the nearest hundredth. So step one, we take the area of the whole sector, ALNM, use the formula for the area of a sector, substitute 9 for r for the radius, and 120 for measurement of m. If we simplify, we get 27 pi centimeters squared. And then for step 2, we want to find the area of triangle LNM. We want to draw altitude NO. We know this is a 30-degree angle. And then LM, right here, is 9 square roots of 3, and h is 4.5 centimeters because we remember that we have a 9 centimeter radius, and so we want to remember that across from our 60-degree angle, which would be this one, we would have a 9 square roots of 3 because we have x square roots of 3. Area equals 1/2 base times height. So 1/2 times 9 square roots of 3 times 4.5 gives me 20.25 square roots of 3 centimeters squared. So step 3, the area of the segment equals the area of the sector minus the area of the triangle. So that would be 27 pi minus 20.25 square roots of 3, which is approximately 49.75 centimeters squared. In the same way that the area of a sector is a fraction of the area of the circle, the length of an arc is a fraction of the circumference of that circle. Arc length is the distance along an arc measured in linear units. So if we are looking at the arc here, L, the length, equals 2 pi r times the measure of the central angle in degrees over 360. For example, find each arc length, give answers in terms of pi, and round it to the nearest hundredth. And we have FG that we're looking for, arc FG. Use the formula. We have 2 pi r measurement over 360. Substitute 8 for r and 134 degrees for m. We have 2 pi times 8 times 134 degrees over 360 degrees. If we simplify, we get approximately 18.71 centimeters. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. An intercepted arc consists of endpoints that lie on the sides of an inscribed angle and all the points of the circle between them. A chord or arc subtends an angle if its endpoints lie on the sides of an angle. So the inscribed angle has its vertex somewhere on the circle, and its endpoints have a chord. This intercepted arc consists of all the endpoints that's on the sides of the inscribed angle, all the points of the circle between them. A chord or an arc subtends an angle if its endpoints lie on the sides of the angle. Let's find each measure. So we want to know the measure of PRU. We find out that the measure of an inscribed angle is half the measure of its intercepted arc. These are the 3 cases you can have. So the Inscribed Angles Theorem tells me that the measure of PRU is half the measure of the arc PU. Substitute 118 for the measure of PU. I have 118 times 1/2 equals 59 degrees. Let's look at a corollary. If inscribed angles of a circle intercept the same arc or are subtended by the same chord or arc, then the angles are congruent. So we see here we have inscribed angles here. They're intercepted. Both of them are intercepted by the same arc. Or they're subtended by the same chord or arc. The angles are congruent. So we have ACB, ADB, and AEB, and the intercept, they all intercept AB. So that means that ACB ADB and AEB are all congruent angles. Let's look at an example. An art student turns in an abstract design for his art project. We want to find the measure of DFA. DFA, this large angle here. The exterior angles theorem gives us that the measure of DFA equals the measure of DCF plus the measure of CDF. So we have DFA equals DCF plus CDF. The inscribed angles theorem says that the measure of DCF plus 1/2 the measure of BC. If we substitute in what we know, the measure of DCF is 33 degrees plus 1/2 of 164. Simplify, and we get 115 degrees for DFA. Another theorem, an inscribed angle subtends a semicircle if and only if the angle is a right angle. An angle is subtended by an arc, line, or other curve is one whose two rays pass through the endpoints of the arc. So in this case, if we have a right triangle, it will hit the endpoints of the diameter, which gives us a semicircle or half circle. In this example, we want to find the value of A. We know that WZY is a right angle. WZY is inscribed in a semicircle. So the measure of WZY is 90 degrees, because that's the definition of a right angle. 5A plus 20 equals 90. If we subtract 20 from both sides, we get that 5A is 70. Dividing by 5, we get that A is 14. Theorem 11.4.4 talks about quadrilaterals inside a circle. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So in quadrilateral ABCD, it's inscribed in circle E. That means that angle A and angle C are supplementary, and angle B and angle D are supplementary. Let's find the angle measures of GHJK. So step 1, we want to find the value of B. We know the measure of angle G and the measure of angle J added together, it has to be 180 because they're supplementary. Substitute the given values and simplify, and we have 9B plus 45 is 180. If we subtract 45 from both sides and then divide by 9, we get that B is 15. Step 2, we're going to find the measure of each angle. Measure of angle G is 3 times 15 plus 25, which would be 70 degrees. Measure of angle J is 6 times 15 plus 20, which equals 110 degrees. The measure of angle K equals 10 times 15 minus 169, or 81 degrees. The measure of angle H plus the measure of angle K equals 180. The measure of H plus 81 is 180. So the measure of angle H is 99 degrees. Now you try. Find the area of each sector, then of segments, and then arc lengths. And then try finding each value. See you in class.